buenos dias, bonjour, guten morgen, buongiorno, ciao shanghao, ohayo gozaimasu. My name is Kimberly Satore from Group 2. Today, we will gonna share with you our research with regards to sedimentary rock and metamorphic rock. But before we proceed with our video presentation or our discussion, I'm gonna share with you a quick review of sedimentary rock and metamorphic rock. I'm going to introduce to you our sedimentary rock. So sedimentary comes from the Latin word sedimentum, means settling. Sedimentary rocks result from mechanical and chemical weathering, comprise 5% of Earth's upper crust. About 75% of rocks at surface contains evidence of past environments. Record house sediment is transported often contain fossils. Now, sediment lose solid particles originating from weathering and erosion of pre-existing rocks. Chemical precipitation from solution including secretion by organism and water. As you can see on the picture above, it will give you a classification by particle size. The classification about boulder, pebble, sand, silt, and clay. Now, you're wondering what's the relationship of sedimentary to Earth system. So actually, we have atmosphere, hydrosphere, and biosphere. Now, we will tackle about atmosphere. So most sediments produced by weathering in air, and sand and dust transported by wind. Now, for hydrosphere, water is a primary agent in sediment production, transportation, deposition, cementation, and formation of sedimentary rocks. Now, for biosphere, it's actually all the product of partial decay of organic materials is found in sedimentary rock. And after this, we will discuss as well the sedimentary environments, the plate tectonic and sedimentary rocks, the types of sediment rocks, the clastic sedimentary rocks, and at the same time, the weathering, the erosion, the transportation, the deposition, and notification. And we will present with you a video about how the process works. So stay tuned and see the next video.
Hi everyone. By the way, my name is Ana Marie Puntaras. Today I will tackle about sedimentary environments. Sedimentary environments, if we look at various environments now present on Earth, we can find characteristics in the sediment that are unique to each environment. If we find those same characteristics in sedimentary rocks, it allows us to interpret the environment of the past. Each environment, its own energy, regime, and sediment delivery, transport, and depositional conditions that are reflected in the sediment deposit. Sedimentary environment can be divided into two. First one is terrestrial non-marine environments. We have glacial, alluvial fans, sand dunes, mountain streams, lake, rivers. Two is marine environments. We have deltas, coastal beach, shallow marine clastics, shallow marine carbonates, and deep marine. Second is plate tectonics and sedimentary rocks. Plate tectonics and sedimentary rocks. Tectonic setting plays key role in the distribution of sedimentary rocks. Occurrence of the specific sedimentary rocks types can be used of constructs past plates tectonic settings. Erosion rates and depositional characteristics give close to each type of tectonic plate boundary. Convergent boundary. Rapid erosion, coarse grain, classic sediment are transported by stream, and turbiditic corians are deposited in basins near mountains. Divergent boundary. Thick wedge of gravel and coarse and along fault, bounded margins of developing rift valley, lake bed, deposits and evaporate rocks are located on the floor of the Rift Valley.
Hello everyone, my name is Melody Arbarkin. I'll discuss types of sedimentary rocks. Sedimentary rock, that real plastic, non-plastic, chemical, and organic, biochemical, organic. Rivers, oceans, winds, and rain or rainfall all have the ability to carry the particles, wash off, or eroding rocks. Such material called the detritus consist of fragments of rocks and minerals. When the energy of the transporting current is not strong enough to carry these particles, the particles drop out in this process of sedimentation. This type of sedimentary deposition is referred to as clastic sedimentation. Another type of sedimentary deposition occurs when material is dissolved in water and chemically precipitates from the water. This type of sedimentation is referred to a chemical sedimentation. A third process can occur wherein living organisms extract ions dissolved in water to make such things as shells and bones. This type of sedimentation is called biochemical sedimentation. The accumulation of plant matter, such as at the bottom of a swamp, is referred to as organic sedimentation. Thus, there are four major types of sedimentary rocks: clastic sedimentary rocks, chemical sedimentary rocks, biochemical sedimentary rocks, and organic sedimentary rocks. Clastic sedimentary rocks consist of solid particles from weathered rocks. These rocks fragments include pebbles, sand, silt, and clay. Rock fragments are a result of physical weathering. The rocks usually form in water environments such as rivers, lakes, oceans, but can also form in deserts. Geologists use particle size to distinguish between clastic sedimentary rocks, as seen is the table below.
Formation of clastic sediments and sedimentary rocks. The formation of clastic sediments and sedimentary rocks involve 5 processes. First is weathering, erosion, transportation, deposition, and lithification. Weathering. The first step is transforming solid rock into smaller fragments or dissolved ions by physical and chemical weathering. Next is erosion. Erosion is actually many processes which act together to lower the surface of the earth. In terms of producing sediment, erosion begins the transportation process by moving the weathered products from their original location. This can take place by gravity, by running water, by wind, or by moving ice. Erosion overlaps with transportation. Next is transportation. Sediment can be transported by sliding down slopes, being picked up by the wind, or by being carried by running water in streams, rivers, or ocean currents. The distance the sediment is transported and the energy of the transporting medium all leave clues in the final sediment that tells us something about the mode of transportation. Next is deposition. Sediment is deposited when the energy of the transporting medium becomes too low to continue the transport process. In other words, if the velocity of the transporting medium becomes too low to transport sediment, the sediment will fall out and become deposited. The final sediment thus reflects the energy of the transporting medium. The last part is lithification. Lithification is the process that turns sediment into rock. The first stage of the process is compaction. Compaction occurs as the weight of the overlying material increases. Compaction forces the grains closer together, reducing pore space and eliminating some of the contained water. Some of this water may carry mineral components in solution, and these constituents may later participate as new minerals in the pore spaces. See next slide for reference.
For this experiment, we will need a sheet pan, damp sand, a straw, ice cubes, a watering can, and a pitcher of water. First, I'll prop up one side of our baking sheet so that it forms a shallow slope, and then I'll place a towel here at the bottom to catch any runoff. You can also do this experiment outside for easier cleanup. Now, we'll start building up our land on the raised side of the pan using our damp sand. You can make it any shape you want with hills or valleys. Make sure to keep it on the top half of the pan. Okay, that looks good. Next, place 2 to 3 ice cubes in the top corners of the pan. Make sure the ice is set in a section of flat sand. Last of all, create a narrow riverbed down the center of the land by pulling your finger through the sand from top to bottom. Okay, we're ready for the next part now. Watch closely as I pour some water here at the top of the pan. See how it looks like a river flowing through a riverbed? Can you see how the water is breaking down our sand riverbanks? This is an example of weathering. Remember that weathering breaks down rocks. Now, look at the water running towards the bottom of our pan. Do you see how it's carrying little pieces of sand with it as it flows? This is an example of erosion. The process of erosion carries the broken pieces of rock and sand away. What do you see at the bottom of our train now? All this sand was carried down our sheet pan and was deposited here at the bottom. This process is called deposition. Remember that weathering breaks the sediment, erosion takes the sediment, and deposition drops the sediment in a new place. Are rivers the only cause of weathering? Can you think of any other ways that rocks are weathered? I'm going to use the straw to weather our sand another way, using the power of wind. Did you see that? When I blew the air, our sand formations broke down from weathering. The air carried away the sand fragments through erosion, and the sand settled somewhere else through deposition. Now, let's simulate rainfall using this watering can and see how that affects our land. What's happening where the rain is falling? Can you see the same processes of weathering, erosion, and deposition? Finally, let's take a look at our ice cubes. Do you notice any weathering or erosion where the ice cubes have been? If you don't see much change, that's okay. These ice cubes are showing us glacial movement, which is a very slow process of weathering. Over time, the ice cubes will slide down, wearing down the land underneath them, carrying away some of the sand with them, and depositing that sand somewhere else. This is one more example of weathering, erosion, and deposition.
Sediment maturity is refers the length of the time that the sediment has been in the sedimentary cycle texturally. Mature sediment is the sediment that is well rounded as rounded increase with transport distance and time, and well sorted as sorting gets better as larger clasts are left behind and smaller clasts are carried away. Because the weathering processes continues during the distance of transport, mineral grains that are unstable near the surface become less common of distance of transport or time in the cycle increase. Those compositionally mature sediment is the composed of the only most stable minerals. So, for example, a poorly sediment containing glassy angular volcanic fragments, olivine crystals, and progly clays in the texturally immature because of the fragments are angular, indicating they have not been transported very far at the sediment is poorly sorted, indicating that the little time has been involved in separating larger fragments in the smaller fragments. It is compositionally immature because it contains unstoppable glass along with minerals that are not very stable near the surface, olivine and progly clays. On the other hand, a well-sorted beach and sand containing mainly as well rounded cracks texturally mature because the grains are rounded, indicating a long time in the transportation cycle. And the sediment as the sorted are also indicative of the long time required to separate coarse grain materials and the finer grain materials from the sand. The beach, it is made of the only grass which is very stable of the earth surface.
Hi, my name is April Sigidokyo. I will share with you conglomerates and breccias. Conglomerate and breccia are rocks that contain an abundance of coarse grained flats, pebbles, cobbles, or boulders. In a conglomerate, the coarse grained flats are well rounded, indicating that they spend considerable time in the transportation process and were ultimately deposited in a high energy environment capable of carrying the large clutch. In a breccia, the coarse grained clutch are very angular, indicating that the clutch spent little time in the transportation cycle.
Hi, I am Charis Pantulio and I will discuss about sandstone.
Sandstone. A sandstone is a sand-sized particles formed in different depositional setting, texture, and composition permit historic interpretation of the transport and depositional cycle, and sometimes allows determination of the source. Quartz, by far the dominant mineral in sandstone. Still, there are other varieties. A quartz arenite is nearly 100% quartz grains, and arkose contains abundant feldspar in a lithic sandstone. The grains are mostly small rock fragments. A waki is a sandstone that contains more than 15% mud, silt, and clay-sized grains. Sandstone are one of the most common types of sedimentary rock.
Hi, I'm gonna share to you about siltstones and shales, mud rock. So first, mud rock are made of fine grains plus shales clay size. Siltstone is one variety that consists of shale size fragment. A shales is composed of clay size particles and is a rock that then flat fragment. See figure 7.6e in your text. A mud rock stone is similar to the shales but does not break into the flat fragment. Organic rich shales are the source of petroleum. Fine grains lactis are deposited in non-aggregated water pump, water little energy to container to transport the small grain. The mud rock forms in deep water, oceans, basins, and lakes. On the next sides has an example of shales, stone, and shales.
Hi everyone, my name is Laila Pinjo. From now, I'm gonna share with you about chemical sedimentary rock.
Chemical sedimentary rock. This rock forms as of chemical weathering dissolving chemical and transporting it in solution. When conditions are right, this dissolved chemical changes back into a solid through the processes of precipitation and evaporation. Precipitation. Process where chemicals dissolve on solution fall out of solution and forms a solid material. Most common in shallow water environment. Evaporation. Process where there are change is state from a liquid to a gas. Chemicals dissolved in the liquid are left behind as a solid material. Precipitation may occur as a result of physical processes or indirectly through life processes of water-dwelling organisms. Sedimentary rock form in his way in repair to as biochemical. Many organisms excrete dissolved minerals to form shales, and when the shales accumulate on the seafloor and form a rock called kakina. Note: evaporation and precipitation often work together. As water evaporates, chemical and solution will precipitate. Example: rock salt. This rock usually forms in water. Environment has lakes and shallow seas or oceans. Some examples of chemical sedimentary rocks include limestone, formed by precipitation. Rock gypsum, formed precipitation and evaporation environment. Rock salt, formed by evaporation. Kakina, formed by biochemical and processes.
Hi, my name is Junre Tagemalay. Church groundwater flowing through rock can precipitate CO to replace minerals that were present. This produce a non-biogenic church can occur as layers or as lumpy nodules within other sedimentary rocks, especially limestones. There are many varieties of structures that are given different names and depending on their attributes. For example, plain or black or green from organic matter, jasper or red or yellow from oxides, and patripid wood and wood grain preserved by silica agent and concentrically layered rings.
Everyone, I am Marilyn Joy Sadiro, reporting about limestone. Limestone is most abundant chemical rock made of the mineral calcite. Most are biochemical but can be organic, often contain easily recognizable fossils. Chemical alteration of limestone in rich water solution can produce marine biochemical limestone from coral reefs, broken shells, and chalk, microscopic organisms. Inorganic limestone include travertine caves and authentic limestone, Bahamas. And that's all. Thank you. I hope you understand and God bless.
Hi guys, my name is Patricia Mamosog and now I'm gonna discuss about what is coal. Coal is a fossil fuel that is formed from the remains of plants that lived and died millions of years ago. It is a black or brownish black sedimentary rock that can be burned for fuel. Coal is one of the most widely used sources of energy for generating electricity and is also used in the production.
Sedimentary structures, feature with the sedimentary rock produced during or just after sediment deposition, provide clues to how and where deposition of sediment occurred. All stages of the sedimentary cycles leave clues to processes that were operating in the past. Perhaps the most easily observable clues are instructions left by the depositional process. We here discuss sediment structures and information that can be obtained in structures. Stratification bedding, rhythmic layering, cross bedding, grounded bedding, non-sorted sediment, ripple marks, raindrop marks, fossils.
My name is Nasilin A. Mangansakan. I'll discuss about stratification and wading. Most common sedimentary structure series of visible layers within a rock because sediment is deposited in low-lying areas that often extend over wide areas. Successive depositional event produce layers called wading or stratification. That is usually the most evident feature of sedimentary rock. A layering can be due to difference in color of the material, differences in grain size, or differences in mineral content or chemical composition. All of these differences can be related to differences in the environment present during the depositional events. A series of beds are referred to as a strata, a sequence of strata that is sufficiently unique to be recognized on a regional scale is termed a formation. A formation is the fundamental geological mapping unit.
Hi, my name is Via M. Landaman. I discuss and write make layering.
Right make layerings, alternating paralayers having different properties, sometimes caused by the seasonal change in depositions verves. Lake deposits wherein coarse and sediment is deposited in summer months and a fine sediment is deposited in winter when the surface of the lake is eroding. Cross-bedding sets the beds that are inclined relative to one another. The beds are inclined in the directions that the wind or water was moving. At the time of the depositions, boundaries between sets of the cross beds usually represent an erosional surface, very common in the beds and deposits and sand, dunes, and river deposited sediment. Graded bedding. As a current velocity degrades first, the large of more dense and particles are deposited, followed by the smaller particles. This result is the bedding showing a decrease in grain size from the bottom of the bed to the top of the bed, sediment added as the pulse of the turbid water. As pulse bends, water loses velocity and sediment settle. Coarse materials hitters first the medium, next then fine. Multiply graded bed sequence called turbidettes.
Hello guys, my name is Norhidaya D. Haji Faisal. I discuss ripples mark.
Water flowing over low sediments creates bed form by moving sediment with the flow. Bed form are linked to flow velocity and sediment size. Ripples are characteristic of shallow water deposition and can also be caused by wind blowing over the surface. Sand dunes are similar but on a larger scale. Ripples are commonly preserved in sedimentary rocks. Asymmetric ripples. Asymmetric ripples as shown above indicate flow direction with the steep slope on the down current direction. Symmetric ripples as a result of constant wave energy oscillating back and forth, small ridge on surface sediment layer by moving wind or water.
Before I start this report, I would like to introduce myself. My name is Jonalyn Elando, and this is my report. My report, it is all about mud cracks. Mud cracks, polygonal cracks, formed in drying mud result from the drying out of wet sediment at the surface of the earth. The cracks form due to shrinkage of the sediment as it dries. When present in rock, they indicate that the surface was exposed at the Earth's surface and then rapidly buried. Then, there are 5 origins of mud cracks. Number 1, water. Fine-grained sediment mud. Number 2, water evaporates and mud shrinks. Number 3, mud cracks develop. Number 4, basin refills with water. Sandy deposits fill in the cover cracks. Number 5, later sandstone layer eroded to show mud cracks preserved. Now we will produce to another topic. It's all about fossils. Trace of plants or animals preserved in rock. Hard part shell bone more easily preserved as fossils. Defense species usually inhabit specific environment. Because life has involved fossils, give class to relative age of the sediment can also be important indicators of plants' climate.
Hi, today I'm gonna share with you the non-sorted sediment, the soil marks, and the range of sediments as you can see on the above picture. Now, sediments showing a mixture of grain size result from such things as rock falls, debris flows, mud flows, and deposition from melting ice. And for salt marks, its floats are through eroded and soft sediment that can become filled with mud. Both the floats and resulting gas called flute gas can be preserved in rock. Now, for raindrop marks or pits or tiny craters created by falling rain, this suggests that the sediment was exposed to the surface of the earth just prior to burial. Now, as you can see in the stones, it has a different color. We have white, we have red, we have grayish, we have black. So rock color is actually sulfides along with buried organic matter give rocks a dark color, indicates deposition in a reducing environment. So deposition and oxidizing environment produce red-colored iron oxide and is often indicative of deposition in a non-marine environment, such as red color rocks are often referred to as red beds. Thank you so much for watching and finishing our video presentation. Once again, this is Group 2 and have a wonderful day. Bye!
Plastic sedimentary.
Hi guys, my name is Patricia Mamosog.
Chemical and transportation. Wait lang.
Go. Hi, my name is Rachel.
Next is transportation. Hello guys, my name is Noridaya D. Haji Faisal.
My name is Via Emlyn.
Sige Dokyo, this is my discuss.
Hi, my name is Nasilin.